It is not permissible to ground the tap at the load side and run it to the house. The National Electrical Code, or NEC, requires that a grounded conductor be used for the neutral return path. This is to ensure safety and prevent electrical hazards. Let's delve into the differences between 2-wire and 3-wire systems. A 2-wire system uses only 2 conductors, a hot wire and a neutral wire. The neutral wire carries the unbalanced current back to the source. A 3-wire system uses 3 conductors, 2 hot wires and a neutral wire. The neutral wire carries the unbalanced current and provides a path for ground fault currents. There are several advantages to using a 3-wire system. Firstly, improved safety is a significant factor. The neutral wire provides a low impedance path for ground fault currents, making it less likely that electrical shocks will occur. Secondly, a 3-wire system offers reduced voltage drop. The neutral wire helps to cancel out the magnetic fields created by the hot wires, reducing voltage drop and improving efficiency. Thirdly, compatibility with modern appliances is crucial. Many modern appliances and devices require a neutral wire to operate properly. Considering a 1,000-foot run, the implementation of a 2-wire system might appear to be a cost-effective solution when considering the materials used. However, it is not a safe or practical solution. A 3-wire system is required to meet the NEC requirements and ensure the safety and reliability of the electrical system. When evaluating such long runs, several factors must be considered, including voltage drop, conductor sizing, and appropriate grounding techniques. Let's address voltage drop first. Over a 1,000-foot distance, voltage drop can become a significant issue. Voltage drop refers to the decrease in voltage along a conductor due to the impedance of the wire. Excessive voltage drop can cause appliances and equipment to malfunction or operate inefficiently. In a 2-wire system, the entire load current returns through the neutral conductor. This can lead to significant voltage drop, especially with long runs and heavy loads. A 3-wire system helps mitigate voltage drop by sharing the load current between 2 hot wires, effectively reducing the current in the neutral wire. This results in a lower voltage drop compared to a 2-wire system. Now, let's look at conductor sizing. The size of the conductors used must be adequate to carry the anticipated current without overheating and causing a fire hazard. The NEC provides guidelines for determining the appropriate conductor size based on the expected load and the length of the run. For long runs, larger conductors may be required to minimize voltage drop and ensure that the equipment operates within its voltage rating. Using 750 kcmil cables is a good starting point, but the specific size may need to be adjusted based on the actual load calculations and the allowable voltage drop. Grounding is another critical aspect to consider. Proper grounding is essential for safety and to prevent electrical shock hazards. The NEC specifies requirements for grounding service entrance conductors and equipment. In a 3-wire system, the neutral conductor is typically grounded at the service entrance to provide a low impedance path for fault currents. This helps to ensure that overcurrent protection devices such as circuit breakers or fuses will trip quickly in the event of a ground fault. Grounding the tap at the load side and running it to the house is generally not permissible and can create a dangerous situation. The NEC requires that the grounded conductor be continuous and unbroken from the source to the load. This ensures that there is a reliable path for fault currents to return to the source, allowing the overcurrent protection devices to operate properly. Furthermore, let's talk about the advantages in a 3-wire system concerning safety. The presence of a dedicated neutral wire provides a low impedance path for ground fault currents. This means that if a fault occurs, such as a short circuit between a hot wire and a grounded metal enclosure, the fault current will flow quickly back to the source through the neutral wire. This rapid flow of current will cause the overcurrent protection device to trip, disconnecting the power and preventing a potentially dangerous shock hazard. In a 2-wire system, the absence of a dedicated neutral wire can make it more difficult for fault currents to flow back to the source. This can increase the risk of electrical shock and create a fire hazard. Regarding voltage drop, the neutral wire in a 3-wire system helps to cancel out the magnetic fields created by the hot wires. This phenomenon, known as magnetic field cancellation, reduces the overall impedance of the circuit and minimizes voltage drop. In a two-wire system, the absence of this magnetic field cancellation effect can lead to higher voltage drop, especially over long distances. Also, concerning compatibility with modern appliances, many modern appliances and electronic devices require a neutral wire to operate properly. These devices often use the neutral wire as a reference point for their internal circuitry. Without a neutral wire, these devices may not function correctly or may even be damaged. In a two-wire system, it may be necessary to install a separate neutral wire specifically for these appliances, which can add to the cost and complexity of the installation. Referring to IEEE Standard 141, insulated conductors for power cables, this standard provides guidance on the selection, installation, and maintenance of insulated conductors for power cables. It covers various aspects, such as conductor sizing, insulation materials, and ampacity ratings. It can be a useful resource for ensuring that the conductors used in the electrical system meet the applicable requirements. In addition, NEC Section 250.24c Grounding of Service Entrance Conductors. This section outlines the requirements for grounding service entrance conductors. It specifies the methods and materials that must be used to ensure that the grounding system is effective and reliable. It is important to comply with these requirements to prevent electrical shock hazards and ensure the safety of the electrical system. In conclusion, while a two-wire system may seem like a less expensive option, it is not a safe or a practical solution for a 1,000-foot run. A three-wire system is required to meet the NEC requirements and ensure the safety and reliability of the electrical system. The extra cost of the additional wire is justified by the improved safety, reduced voltage drop, and compatibility with modern appliances. When designing an electrical system, it is always important to consult with a qualified electrical engineer or contractor to ensure that it meets all applicable codes and standards. They can assess the specific needs of the installation and recommend the best solution to meet those needs. Remember, prioritizing safety and adhering to established electrical codes are paramount for any electrical installation, especially over long distances. These standards are in place to protect individuals, property, and to ensure a reliable and functional electrical system.